All right, for 8.3, we're going to use what we know about matrices, and we're going to find the determinant of a 2 by 2. Okay, so it's got to be a square matrix, 2 rows, 2 columns. We're going to find the minor and the cofactor of a 3 by 3, which is the first step of finding the determinant of a 3 by 3. It's just slightly more complicated. And then we're going to solve a system using Kramer's rule. So first of all, the determinant of a 3 by 3, of a 2 by 2. So I'm going to go through your homework and we're going to show you how to find the determinant. So again, the way I read this is 86x's minus 78y's. I don't know what the answers are. They're somewhere off in a different matrix that wasn't given to me. So the determinant is you cross this way, so 86 times a negative 39, and then subtract. You always subtract. So cross this way and multiply, and then 43 times negative 78. So when I multiply this in my calculator, 86 times a negative 39 is going to be, hang on, negative 33.54, and then minus, always subtract, 43 times a negative 78 is a negative 33.54. So when I change signs, I end up with a negative 33.54 plus 33.54 is 0. Now, one of the cool things about determinants is that if I did have the answer matrix, okay, what I do know is that these two lines are either parallel or they are the same line, one of the two. But your answer for the determinant is 0. Okay, so let's try it again. I've got a negative 36 times a 42 minus 29 times 1. So a negative 36 times 42 is a negative 1512 minus 29. And that gives me negative 1541. So your determinant is a negative 1541. Okay, so let's do this way. We've got 5AC times 5BD. So that's going to be a 25 ABCD. So cross this way. Minus, cross this way, gives me 10 ABCD. Well, 25 of those minus 10 of those is 15 ABCDs. So you have 15 ABCDs. Okay, that's a 3 by 3, that's a 3 by 3. Okay, so let's do minors. So I'm going to find the minor of a 3 by 3. So again, this is step 1 towards finding the determinant of a 3 by 3. I'm just not taking you that far. So we're going to find the minor first. So the minor, what it's asking me to do is say determine the minor of A12. So here's my minor. A12 is first row, second spot. Okay, so it's a negative 4. I'm going to kill that row and kill that column. So kill his row, kill his column. And now what's left? What's left is you have a 7, 4, 4, negative 7. And all you need to do is find that determinant and you're done. Okay, so cross this way, I get a negative 49 minus, cross this way, I get 16. So negative 49 minus 16 is going to be a negative 65. So I get a negative 65. So that is the minor of that matrix. So let's try it again. So I want to find the minor of A22. Find the minor of A22. So A22 is second row, second spot. So I'm going to kill his row and I'm going to kill his column. And then I'm going to find the determinant, of what's left. So what's left is 3, 3, 3, negative 8, and find that determinant. So I get a negative 24 minus 9 gives me a negative 33. So that is your minor. Okay. And again, that's just step 1. So you're like, why am I doing this? Because if we were to find the determinant, we would need that information to find the determinant of the larger matrix, but we're not going that far. All right, so now find the cofactor. So how can I remember the difference between a minor and a cofactor? A minor, you have to find the minor before you can find the cofactor. So cofactor is like two words, like company, cooperative, co. Okay, so you have to find the minor first, and then you can go to the cofactor. I don't know if that helps. So here's what we're going to do. We're going to find the minor first, and then I'll tell you what the cofactor is. So it says find the cofactor of A13. So first row, third spot. I'm going to kill that row. I'm going to kill that column. And I'm going to find the minor, or the determinant, sorry, of what's left, which is the minor. So 5 times 8 is 40, minus 8 times 3 is 24. So I get 16. So the minor is 16. Now, what is the cofactor? The cofactor is either positive 16 or negative 16. I just got to figure out if I need to change the sign or not. So here's how you figure it out. Look at your A13. I found the minor of A13. Add these two together, and you get a 4. If it's even, you leave it. So if it's even, you leave it. If it's odd, you change. Well, 4 is even, so my answer, I leave the sign alone. My answer is 16. Okay? So let's do another one. I've got the cofactor of A32. So the cofactor of A32. So third row, second spot is a 1. So I'm going to kill his row. I'm going to kill his column. And I'm finding the cofactor of A32. So the determinant of what's left is 2 times 8 is 16, minus 8 times 4 is 32. So my minor is negative 16. So do I make it a positive 16 or do I leave it a negative 16? We'll add these two together, and that's 5, which is odd. If it's odd, I change. So it was a negative 16, but my cofactor is a positive 16. So cofactor, you need to determine if you're going to change the sign or not. And if this adds up to an odd, you change the sign. If it's even, you leave it. And now we're going to do Kramer's rule. You can use substitution on this. You can also use elimination on this. I don't care. But I'm going to show you Kramer's rule because some people absolutely love it when they see it. So the first thing I want to do is find the matrix, the coefficient matrix of what I'm given here. So I've got a 9, a negative 9, and a negative 63. And then I got a 5, and an 11, and a 93. So what I want to do first for Kramer's rule, and again, I'm going to figure out if this is a point or if there's no solution, whatever. I'm going to ignore the answers first. I'm just going to find the determinant, okay? So the determinant, 9 times 11 is 99, minus 5 times negative 9 is negative 45. So I get a positive 144. Now, that is the denominator of your xy coordinate. Okay, so my denominator is 144. Now, if I want to answer x's, I put the answers in for x. Okay, so the y's I'm going to leave alone. So he's a negative 9 and 11, and I'm going to put the answers in for x. So negative 63 and 93. And then I'm going to find the determinant. That'll be my numerator. Okay, so all I did was take this matrix, and if I'm going to answer the x's, put the answers in for x's. And now find the determinant. So negative 63 times 11 is going to give me a negative 693, minus 93 times negative 9 is a negative 837. Okay, you can't see. There we go. And then, out. All right. I'm going to add those two together. So negative 693. Or sorry, I'm going to subtract them. Just kidding. Which means I add because mine is negative, is 144. So my numerator on x's is 144. So now, guess what? Go back to the original. If I want to answer the y's, so if I want the answer for y, put the answers in for y's. So I'm going to leave the x's alone this time. So I got a 9 and a 5, but put the answers in where the y's were. So that's a negative 63 and 93. And then find the determinant. So 9 times 93 is going to be 837 minus 5 times 63 is 315 negative. And when I do that, I get 1152. So I took the answers and put them in for y, and I found the numerator or the answer for y, which was 1152. So now when I reduce these, I'm going to get nice pretty numbers. You won't always, but we will today. All right, so 144 over 144 means my x-coordinate is a 1, and 1152 divided by 154 gives me a y-coordinate of 8. So again, if you had used substitution or if you'd used elimination or anything like that, you would get the same answer. But if you want to do determinants, some people think that that's just a quick, easy way to do it. So I won't know which method you use as long as you do your method correctly. So I don't care what method you use. But that is 8.3.